Hello everyone, this is the second lecture from the HSTR lecture series. We started electronics chapter last time in the first video. We are going to continue that chapter in this second video as well. Before starting the video, I have a humble request. If you have not watched the first part of this series, then please stop this video now, pause it, go back to the first video of this series and you watch it first. Because in that video, I have explained thoroughly everything about electronics introduction, conductors, insulators, energy bands, then forward and reverse bias, doping, dopants, and all about PN junction diode. Without understanding these concepts, this class, it will look very blunt to you. You will not understand many things from this present class if you have not attended the previous class. So please go and attend the previous class first. I will give the link in the description also. You click the link in the description and then you first watch the first video of this electronics chapter. Okay. Now in this video, I am going to discuss on LED, photodiode, solar cell and transistor. Firstly, these LEDs, photodiodes and solar cells, they all come under optoelectronic junction devices. They are all made of semiconductor diodes, basically a PN junction diode. In these diodes, the carriers, they are generated by photons. Carriers means, remember in our previous class, we talked about the majority charge carriers, right? Majority charge carriers were electrons and holes in a PN junction diode. So, the same funda applies here also, because these diodes are all made of PN junction diodes only, but there are some differences, there are some changes in that, there are some fabrications in that so as to make them as other type of diodes like photodiodes, light emitting diodes and solar cells. Okay. Here the main important thing is that here the majority charge carriers, whatever they carry the current, they are generated by photons. Photons means they are packets of light, right? Photons are packets of light. Basically, here light is utilized in these semiconductors to produce the current. Okay, this you have to remember. Now, according to your syllabus also, there are three types of optoelectronic junction devices about which we have to study. First is photodiode. Basically, it is a photodetector. Photo means light, remember. Okay. Photodetector. It will detect an optical signal. Then light emitting diode. The abbreviation is LED. Okay. LED. It is a very common name. You all must have heard it. This is used to convert electrical energy into light. And third one is solar cell. Solar cell, it is a type of a photovoltaic device, you can say. Here it will also convert optical radiation into electricity, but the operation of all these three diodes is different. We will discuss one by one, and one compulsory question will come among these. Okay, for 1 mark, one compulsory question will come in HSTR and CRIS also. So carefully you hear whatever I am discussing. If you have any doubt, you please let me know in the comment section. First, let's talk about photodiodes. These photodiodes, they are used for detecting optical signal. Okay, they are also known as photodetectors, and this is the symbol. There is a PN junction diode and then the two arrow marks, they indicate that the light is falling on that PN junction diode. Now, there is a simple difference. What is the simple difference between the PN junction diode and the photodiode is that basically photodiode, it is a PN junction diode only, but it is specifically, it is fabricated with one transparent window in the place of the depletion region. Okay, that transparent window, it will allow the light to fall on it. It will allow the light to incident on the diode. With this light, then again current flows through the circuit. Okay. Now, if you see this circuit carefully, the way the PN junction diode is connected in this circuit, here the P side is connected to negative terminal of the battery. So, what biasing is this? It should be reverse biasing, right? Remember, in our first lecture, we were talking about forward bias and reverse bias. What we were doing in forward bias, the P side region was connected to the positive terminal of the battery. Isn't it? It was a forward bias. If the P side region of the PN junction diode is connected to the negative terminal of the battery, then it was a reverse bias. So here P side region is connected to the negative terminal of the battery. So it should be a reverse bias condition. So the moral of the story is that the photodiode, it is operated in the reverse bias condition. Why it is operated in the reverse bias condition? Because you see here in the circuit only, the ammeter, it is connected only for a microampere. We get very small current. Small current means reverse bias. More current means forward bias, isn't it? We were talking all about this in the first lecture. That's why I requested you all to first watch the first lecture. If you watch that lecture, then only you can understand all this. What I have done is, in my first lecture, I have discussed everything very thoroughly, in deeply. Now I am not going to do that in the rest of the videos for this chapter. Because once your base gets strong, once your fundamentals get strong, then you can understand everything very easily, right? That's why I was telling you to go and watch that video first. Then again come back and watch this video, okay? Now, this photo excitation or the light which falls on this depletion region, it will result in a change of reverse saturation current, okay? That's the reason why we will plot the IV characteristic for photodiode in the reverse bias condition. Remember, in the forward bias condition, the current was in milliamperes, right? In reverse bias condition, it was in microamperes. Here, the photodiode, it is giving us current in microamperes. Okay? So, photodiode, it is always operated in reverse bias condition. So, one question can be asked like this. Photodiodes operate at. So, the answer must be reverse bias condition. So, what is the difference between a PN junction diode and a photodiode? Photodiode being a PN junction diode, it is not operated at forward bias. Remember, PN junction diode was operated only in forward bias. But photodiode is operated in reverse bias. What is the one more difference? One more difference is that these photodiodes, they are optoelectronic devices. If light falls on it, then only it will work. Okay. So this was about photodiodes. Now, light emitting diode. Light emitting diodes means LED. They are very commonly known as LEDs. You know it, right? Everywhere it is there nowadays. All the bulbs and everything, they are all replaced by LEDs only. You can see one small light in your remote control also of your TV. One small light at the top in the middle. So that is a LED. It is used as a sensor in the remote control. Okay. So what is the work of this LED? It is used to convert electrical energy into light. It will take electrical energy, then it will give you light. Now this is the symbol of a light emitting diode. You can see the 3 arrow marks which are away from the diode. That means it is giving you light. Okay, it is giving you light. It is a PN junction diode only. But it will give you light if you give electricity. It will convert electric energy into light. Now the speciality of this LED is that it will produce a different type of frequencies. It will give you different colors of light. Okay, this is one very important speciality of LED. And it is also a PN junction diode, and same like PN junction diode, it will also operate under forward bias. Remember, you can see here the P type of the diode is connected to the positive terminal of the battery, isn't it? And the N type is connected to the negative terminal of the battery. So this is operated under forward bias. Now energy of this emitted photons, no? The energy and the color which is produced from this LED, it will depend on the material with which you are making this LED. Okay, it will depend on the nature of the semiconductor or the band gap of the semiconductor with which you make the LED. If there is change in band gap, means for particular band gap, particular color of light this LED will produce. Okay, we will not go into so much details because it is not needed. But one thing you have to remember is that if you want to change the color of the LED, then you have to change the material which is being used, the semiconductor material which is being used to make this LED. Now, why these LEDs have become so much famous? Because they have a lot of advantages, right? In place of this normal conventional electrical light sources, nowadays all prefer using LEDs. Why? Because first point is that they will use very less of power. They will consume very less power, but they will give you equal amount of energy. They will give you equal amount of light, sometimes more light. Okay. And then they will not spoil soon. They will last longer, means wear and tear, and it is more durable. You can handle it roughly also, they will not be spoiled very soon. Okay. So these are the reasons why we prefer light emitting diodes. Now one type of question can be asked here. LEDs in reverse bias condition, they emit brighter light, dimmer light, same as in forward biasing, no light. See what I told you, in PN junction diode it operates under forward bias. So does LED. LED also operates under forward bias. So it means that it will not operate under reverse bias, right? So if it is not operating under reverse bias, means it will not give you light. So no light will be the answer. Okay, next are the solar cells. These solar cells, they come under photovoltaic devices. They convert optical radiation into electricity. But then you will tell that, what madam, even photodiode, it is also converting optical radiation into electricity. I agree with you. Solar cell is same as photodiode. But there is one difference. That difference you can see if you see this circuit carefully. There is no battery here. Isn't it? Is there any battery? Is there any voltage source in this circuit of solar cell? No. That's the speciality of solar cells. They don't need any input electricity. For them, the input is the solar light, the light from the sun. Okay. Now this is the symbol of the solar cell. Here you can see that it is taking the light, the two arrows, the incident radiation, it is falling on the solar cell. It will take that light and it will give you current. Okay. Now as I told you, it is same like PN junction diode only, and that too particularly the photodiode. But then here you have one large sensitive area on which the solar radiation, the light from the sun falls. Okay. Now this incident light, it will generate a electron hole pairs. That is what happens in the depletion region, right? What happens in the depletion region? Electron hole pairs are generated. Like same in the PN junction diode. Here also that will happen. But that will happen not with the current. That will happen with the sun's light. Okay. Now what will be the working of this solar cell means? Here you can see that we don't know whether it will be forward bias or reverse bias because we are not at all connecting any battery in the circuit. But then you see the direction of the current. The current outside the junction, it will go from P to N, isn't it? It will go from P to N outside the junction. But what will happen inside the PN junction diode? We know that electrons move from N to P first, right? When electrons are moving from N to P first, then what will happen? The current is moving from N to P inside the PN junction diode. But outside the PN junction diode, current is moving from P to N. Okay. So that's the reason why you plot a graph like this. There is a negative current here. The negative current means you will plot graph in the fourth quadrant. Here IV characteristic will be very much different. Here you don't know the voltage. Isn't it? That voltage, it will be a open circuit voltage because you are not giving any voltage here. You don't have any source in the circuit. But then what will be the current? Current will be negative. Okay. So this is a typical IV graph for a solar cell and it is very much different from other diodes, especially the PN junction diode. So you have to remember this graph also. They may give this graph and then they may say that this graph, it resembles LED, solar cell, photodiode or a PN junction diode. You should note that this is a solar cell graph. Okay. Now these are the expected MCQs from this part. First is LED is the abbreviation of. This is very simple. You know it is light emitting diode. Next is a light emitting diode is. There are 4 options. It always used in forward bias. It is used in reverse bias. It is never used in forward bias. It is used both in forward and reverse bias depending upon its application. So when we know the right answer, we don't go to see all the options also, right? Now we know that it is always used in forward bias. It will not work in reverse bias. In reverse bias, it will not give you light. So option A will be the right answer. Next question. Color of light emitted by LED depends on. It depends on type of semiconductor diode used to make that LED. Okay. Now the summary is, see actually these are all special diodes. We were talking about Zener diode also in the last lecture, right? So the Zener diode, photodiode, LED, solar cell, these are all special diodes. They are all made using the PN junction diode. Now what are the applications? Just let's have a look, like sort of a summary. We should know what it is, right? So Zener diode, it is a highly doped PN junction diode. First point. Then is the speciality of Zener diode is that it is used as a voltage regulator. Now photodiode. This is also a PN junction diode, but it will detect a light only in reverse bias. Then LED, it will emit optical radiation only under forward bias. Then solar cell, it will generate EMF of its own due to effect of sun's radiation. Okay, so these are the 4 points you have to remember regarding these diodes. Now one more question can be asked like this, based on all this part of this diodes, especially for Christ people. They may ask this type of a question for you all. Match column 1 and column 2 with appropriate matching. Means you should know everything about all the 4 diodes, then only you can answer this question. See here the PN junction operating in unbiased condition. What is that? That is solar cell, because we are not at all connecting any battery there. We don't know what is the biasing there. We don't need basically. Then used as a AC voltage stabilizer. You all know it very nicely now, isn't it? It is Zener diode. Then in remote control receiver, sensors used are, they are of course LEDs. Just now we talked about this. Then electric potential energy is converted into electromagnetic energy. This is done by photodiodes. Okay. So option B should be the right answer. Okay, this was all about diodes. I think this was more than enough. Now you don't need to read anything. Just you attend this class. See, when you attend my classes, no, you can relaxedly attend the classes and write the notes. You don't need to read anything else again. My classes will be more than enough for your HSTR and CRIS. Okay. Only request is please patiently watch the full video. Don't watch little bit. Then what you will grasp, what you will understand, what you will make notes. See, or whatever I am working hard also will go waste. And you also simply are forwarding the lecture and you are not attending it properly. You will also not understand anything. So when I am working hard, I expect that you all also work hard. You all watch my full video. Then only it will be helpful to you. Okay. So next, let's talk about transistors. Now transistors means they are also one devices which are made using the PN junction diodes only. They are operated by current. Their important application is that they amplify the signal. That means you give little current, they'll give you more current. Whatever signal you are giving as input, they'll give you more of it. Okay. Basically, transistors, they are bipolar junction transistors. Bipolar means they have 2 junctions. If they have 2 junctions means, see in PN junction diode, there were 2 materials, P and N. Junction was 1. Isn't it? There was 1 junction. The depletion layer, the junction was 1 between P and N. Now I am telling that they have 2 junctions. So if you have 2 junctions means how many materials should be there? There should be 3 materials. Isn't it? If 3 materials are put together, then only you can have 2 junctions between those 3 materials. Isn't it? Now this PN junction diode, no, it is used in a different way in transistors. Basically this transistor, it will contain 2 junctions back to back. Either it can be PN and NP or it can be NP and PN. And basically they consist, these transistors, they consist of 3 main regions. One is emitter, second is base, third is collector. It looks like this. I am sure you all must have seen in the lab also in your BSc. If you have done BSc practicals, lab practicals, I am sure you must have seen the transistor also. So in that transistor, emitter is denoted by capital E, base is denoted by capital B, and collector is denoted by capital C. What does emitter do? It will provide you the majority charge carriers, okay, which will carry the current in the transistor. Basically in the transistor, no, emitter is the hero, you think. Emitter is, everything is done by emitter only in the transistor. So the hero of the transistor is emitter, you remember. Then because it is having lot of work to do, that's why emitter, it will be heavily doped. Then base region, you denote it by capital B. It is the most thinnest layer in this transistor and it is very lightly doped. And collector C, it will be the moderately doped. Between the emitter and base, you can say how much it is doped, means it is moderately doped. And then the collector, no, it is having larger region than emitter and base in the transistor. Okay. Now these transistors, they can be of 2 types. They can be NPN or PNP. So this is the symbol of a transistor. Here NPN transistor, you can see in NPN transistor, emitter when you see the way I have put the figure here, no, you connect it in the same way in a circuit. Just you draw a circuit in the both of the sides, then that's it. This is how you connect it. Here in NPN, no, your majority charge carriers, they will flow through the emitter to the ground, you can say. Okay, they are moving through the emitter. But in PNP, no, they are moving through the emitter away from the ground. They are moving towards the base, you can say. They are moving towards the base. Now, what are the majority charge carriers in NPN and PNP? We will talk all about that. This, I am just telling you about the symbols, how you draw the transistor. The transistor, it will have one emitter, collector and base. Okay, only so much you remember now. Then I will go into more detail now. Moving forward, let's talk about NPN transistor first. See, when I say NPN transistor, here you can see how they are sandwiched together. N, P, N. This N will give you emitter region, P will give you base region, and another N will give you collector region. Okay, so every time you put one arrow in the emitter, whether the current is moving into or away, you put arrow in the emitter only. You don't put arrow in the collector or base. Okay, so here I have shown you how this PN junctions they are made. N, P, N. Now you know that what are the majority charge carriers in N? They are always electrons, right? So you know it. We also told that the majority charge carriers, they flow from emitter to base. So here, because it is a NPN transistor, the majority charge carriers, which are electrons, they will flow from emitter to base. Okay, this you can remember. If you just remember this figure, you will imagine and you can remember what are the majority charge carriers, right? Just remember that N means majority charge carriers are electrons. So much is enough here. Now, how it is connected also you can see. Here in this circuit diagram, NPN, N is emitter right here. That N is connected to negative terminal of the battery. That means it is forward bias. If P is connected to positive terminal of the battery or N is connected to negative terminal of the battery, then you call that it is forward bias. Then what is happening in the collector region? There the N is connected to the positive terminal of the battery. That means it should be reverse bias. Okay. So one is forward bias, the other one is reverse bias. So this was about NPN transistor. Now in PNP transistor, you can see here in NPN, both N's were there and P was in the middle. In PNP, both P will be there and N will be in the middle. And because we are talking about two regions which are P, that means your majority charge carrier should be holes, isn't it? So here majority charge carriers are holes and they flow from emitter to base. Okay, this you have to remember. And then here emitter is P, right? That is connected to positive terminal of the battery. That means it is forward bias. And in the collector region, collector means it is P, right? It is connected to negative terminal of the battery. That's why it is reverse bias. So much you can remember. Now basically, whatever it is, either it is a PNP transistor or a NPN transistor, always this emitter current is equal to the sum of the currents from base and collector. IE is equal to IB plus IC. This you remember. Only so much is very important. IE is equal to IB plus IC, whether it is a PNP or a NPN transistor. And one more thing is that when you connect this transistor in a circuit, no, it is always joined such that emitter based circuit, it is always forward bias, and collector based circuit is always reverse bias. That you have seen in the circuit diagrams also. Now these transistor, no, you can connect them in a circuit in three type of configurations. Either you connect in a common emitter configuration, or you connect it in a common base configuration, or you connect it in a common collector configuration. Common emitter configuration means your emitter you connect directly to the earth along with the circuit. And then common base means you connect base to the earth. Then again collector means you connect collector to the earth, but one thing is that collector is always there with the battery. Okay, so this you have to remember. And then direction, no, whatever you connect, however you connect, wherever your emitter is there only your arrow mark will be there. Okay, only thing is it is dependent whether the transistor is connected in forward bias or reverse bias. if you have connected it in forward bias, current will go into the emitter. If you are connected in reverse bias, then it will be away from the emitter. That you have to see the directions. Okay. So see, much of transistor is not asked in your previous year HSTR question paper, but you never know. At least you should have an idea, right? That's why I'm not going into much deeper. I'm not putting you in trouble with numericals and all that. Okay. But one important question which may be asked, in fact, I'm expecting this type of a question from transistor this time, even in CRIS also, that will be using these formulae of current amplification. I told you that transistor, it amplifies current, right? Now, how does it amplify current? We have to calculate that, right? So, if it is a common emitter transistor, then the current amplification, it is denoted by beta. This will be equal to change in collector current upon change in base current. Remember, in common emitter configuration, you are taking the ratio of the currents of collector and base, not the emitter. Okay. So, the gain here, the current amplification or the gain, you say gain also. Gain in common emitter configuration will be the ratio of change in current of the collector upon change in current of the base. This comes out to be one constant number always, that is equal to around 19. Okay, you have to remember this number also. They can ask you in 1 mark, this MCQ question. Next is, if your transistor is in a common base configuration, then it is denoted by alpha. This current amplification or gain, it is equal to the ratio of change in collector current upon this emitter current. Okay, remember, if it is common base means you are taking ratio of current change in collector and emitter. This number comes out to be 0.95. It is a constant. Now these alpha and beta also, they are interrelated. How they are related? Alpha is equal to beta upon 1 plus beta and beta is equal to alpha upon 1 minus alpha. So what they do is they give you alpha and they tell you to find beta, or they give you beta and they tell you to find alpha. Sometimes they also give you current across collector and base or current across collector and emitter also. Using those values also you can find out. Okay, whatever the parameter they are asking you, you can find out. Now along with amplification, these transistors, they have two more very good applications. First is that transistor, it can be used as a switch. Here in the transistor, there is the base, right? In that base, no, if you give current, the transistor will act as a on switch. If you stop giving current at the base, then the transistor will act as a off switch. Okay, so you can use transistor as a switch. Next is, I told you about the amplification, right? Transistor can be used as an amplifier in common emitter configuration. Here what happens? If the input circuit, no, if it is base emitter circuit, then it is forward bias. Then output circuit, it will be always reverse bias. That will be collector emitter circuit. We have talked about this in the circuits also, right? Third is a very important application. Along with switch and amplifier, transistor can also be used as an oscillator. Now what is an oscillator? Oscillator means it is an electronic circuit. It produces AC output voltage. If you not give any input voltage also, any external input voltage also, it will give you output voltage as AC output voltage only. Okay, so this is an oscillator. Now in electrical oscillating system, you will have two components. Inductor denoted by L and capacitor denoted by C. They are always connected in parallel. Okay, with each other they are connected in parallel, and this type of circuit is known as tank circuit. Remember, transistor used as a oscillator, the circuit is known as tank circuit, in which inductor and capacitor are connected in parallel to each other. Now the frequency, we are talking about AC, right? Alternating current. So we should know the frequency. The formula for the frequency is 1 upon 2 pi into root of LC. L is the inductance, C in the capacitance. If they give you inductance and capacitance, you can find out frequency. Or if they give you frequency and inductance, you can find out capacitance. Or if they give you frequency and inductance, then you can find out capacitance. Whatever. They will give you two parameters, one parameter you have to find. Okay. Now let's see about the MCQs. What type of questions may be asked? First question is, the value of current gain alpha of a transistor is 0.98. The value of beta will be. Now we know the formula, right? Beta is equal to alpha upon 1 minus alpha. Alpha is given. So I substitute and I find the value of beta, which comes out to be 49 here. Then when NPN transistor is used as an amplifier, electrons move from collector to base, holes move from emitter to base, electrons move from base to collector, holes move from base to emitter. See, NPN. NPN means holes should move from base to emitter. Okay. Next question is the heavily and lightly doped regions of a bipolar junction transistor. They are respectively, of course, they are emitter and base. The heavier doped is emitter, the lightly doped is base, collector is the moderate one. Okay, that's all for this lecture. If you like my work, please like the videos, share my videos and also subscribe to my channel. Thank you.